In this video, we're going to be going over some basic limit properties which are useful in future proofs of derivatives and in future usages in calculus. Our first limit is the limit as our input of x or any other variable approaches to a number of n of the sum of two functions represented by f of x and g of x is equal to, if we break up the limit, as the limit as x approaches to the number of n of f of x plus the limit as x goes to n of our second function g of x. And our second limit property, which we're going to be analyzing, other than the sum of two functions, is the subtraction of two functions. So when the limit, our input of x, approaches to any number of n, of the subtraction of two functions represented by f of x and g of x is equal to, if we break up that limit, likewise to how we did it for the sum of two functions. So this becomes the limit as x goes to n of f of x minus the limit as x goes to n of g of x. And these are our first two limit properties, which are essential to memorize in calculus. They are the limit of the sum and subtraction of two functions. And now we're moving on to the product of two functions, when our input of x approaches to the number of n. So the limit of f of x times g of x, as our input of x variable approaches n, will be equal to, if we break up this limit, the limit when x goes to n of f of x times the limit when x goes to n of our second function g of x. We can see here in all of these three examples that the limit penetrates the function for which we are performing a certain action towards, such as plus, minus, and multiply. And now moving on to division. The limit when x approaches to n of the division of two functions represented by f of x and g of x. So this will be equal to, if we penetrate the limit into our ratio. This is the limit when x goes to n of f of x divided by the limit when x goes to n of our second function g of x. In all of these four examples, the limit penetrates, which I've already stated, but I'm going to repeat for better understanding, that the limit penetrates the two functions for which we are performing a certain arithmetic action towards. That is for the plus, minus, multiply, and division. And now with these limit properties, these four basic limit properties, we can move on to some more specifics, which are some alternate uses of these applications of these properties. So more limits properties are the limit when x approaches to 0 of sine of x over x. This limit is equal to 1. And the reason why this is equal to 1 and why this limit is important is because when x approaches to 0 for this function of sine of x divided by x right here, there will actually be a hole, because we have a form of 0 divided by 0. Sine of 0 degrees is 0, or radians rather, sine of 0 radians is 0, and 0 divided by 0 is not defined. So that is why this limit is important to memorize. We'll be proving this limit in future videos. Another special limit is the definition of e in terms of a limit. So that is the limit when x approaches to infinity of 1 plus x, 1 over x, raised to the x power is equal to e. The e is a natural number. E has an approximation of 2.71. And that is the limit definition for our natural number of e. And another way to write e in terms of a limit is the limit when x goes to 0 of 1 plus x raised to the 1 over x power. And this is actually a very simple thing to memorize, because when 1 is divided by an infinitely large number, such as infinity, this 1 divided by x ratio will infinitely approach to 0, which is why we can see here it becomes 1 plus x instead of 1 plus 1 over x. And 1 divided by 0 is undefined, or in other words, 1 divided by 0 will approach infinity, because a big number divided by a small number will be a big number. That is the same reasoning for our previous definition for e, because when this entire quantity is raised to the infinite power, it will go to the infinite power. Likewise, when we divide 0 in the denominator, 1 divided by 0 will never become infinity, it will infinitely approach infinity. This will also be equal to e. And in this video, we're going to be wrapping up this part 1 series of basic limit properties essential for calculus.